Good morning. Welcome to the GSE UK Conference 2021. Malcolm Beattie is going to talk to you about zVM platform update and expanding the horizon. This is session 2AS, and over to you, Malcolm. Oh, and by the way, any questions in the chat, please?
Okay, thanks, Dave. Indeed, if you put questions in the chat, but whenever you like, so I'll sort of take and answer questions all the way through, and I'll also leave a gap of some size. We'll have to see how long at the end for questions as well, but don't feel you have to wait until then. So hello everybody, I'm Malcolm Beattie. This presentation, unlike last week's one, isn't mine. I didn't write it. This is the kind of the standard zVM platform update written by Bill Bittner with the help of his colleagues, but I'm delivering it. I'm doing it today. And these are the GSE charts, so a reminder about the GSE charity raffle and a reminder about how to become a member of GSE. And on with the presentation. So there's a link on here that you can see to the link for the latest version. So what's just happened recently is there used to be a platform update presentation, and there used to be a separate leveraging the new functionality presentation. And what they're just in the middle of doing is combining them into a super deck. So what I've done for today's session is taken the charts for the platform update, but not the leveraging one. When you go to that library presentations there, I'm not quite sure how things are going to appear, whether you'll get kind of the option of the update, the leveraging, and the overall super deck, or whether it will still kind of appear to be two separate ones. But just so that you know, if you see some extra material or wonder where things have gone, that's how things are changing. So I'll go through the usual, what are the current releases, and the 2-year cadence, which we're kind of settling into now. Then an overview of 7.2, so the current release. And then enhancements that have been introduced in it, and the various subject areas there, which are the focus of these. And then a few bits and pieces at the end. So there's quite a lot of charts. Most of these I'll try and go through quickly, but a few of them I'll spend a bit of time talking about because I think they're more interesting than others, or there are some things I want to draw your attention to. So here's a release cycle cadence, and we should all be fairly used to this by now, but it's always worth a reminder. I always have to sort of have a look and remind myself of exactly how the timings work, but I'm just about getting used to it. So GA for each release now is in the 3rd quarter of even years, so that doesn't overlap with the ZOS release cadence, which is 3rd quarter of odd years. Each release is in service about 4.5 years. And what you can see now in this cadence chart is that there's kind of a bit more extra information, so that you can see over here along the 7.2 row that when the general availability happens, there are then new functions enhancements introduced each quarter. And what you'll see above that with the RSU line, before it was just kind of an RSU comes out, you know, when it's ready, and you've probably seen they tend to be about, you know, a couple of a year, but not always. And what's kind of happening now is that is also being sort of nailed down a bit in order to give customers fewer surprises, more ability to plan. So the idea is that the RSU at the beginning comes out as always, so the thing ships with the main image, and then an RSU image that gets put immediately on top of that, and then 2 RSUs within that next year, and then 1 RSU, and you can see kind of the frequency decreasing there. So 6 RSUs for the life of a release. That's the plan. That's the plan. And then you can see, as usual, you've got the withdrawal from marketing towards the end. And as always, if that time is approaching, don't forget to make sure that you've got a release ordered. It isn't end of service. You're still, eligible to keep using it, but from that point, it becomes, you can't just go and get it from Shop Z. So it's always worth making sure that you've got, before a release gets withdrawn, order it, order the latest RSU, keep it somewhere safe, even if you weren't planning to use it, just in case. And the SCs there, the service and processor compatibility. So even after a new release comes out and supersedes the old one, so here we've got a new 7.x release coming out 3rd quarter next year. New function immediately goes into this one rather than the previous release, but the previous release is still getting support for any new hardware, hardware generations and so on that comes out, and service and so on, until it then goes end of service. So the usual table of releases, 7.2 has now been out there for over a year. Timing has been rather weird the last couple of years or so, but yep, that's the way it is. And here's the table of compatibility. And one of the main things you can see there is the new architectural level set for 7.2. So it's Z13 generation and up only. And there's an explicit comment there that the 2828, in other words, the ZBC12, which is the latest of the previous generation, does not meet the ALS requirements, so it is not supported. And the reason it says ZBC12 there in this table at the bottom, it kind of confused me a little bit. Why is it talking about the ZBC12? The order they've put these things in isn't time order, so they've sort of put little big, little big, little big, but of course in practice the EC12 comes out before the BC12. So the BC12 was the previous, the latest hardware before Z13, but no, it doesn't meet the ALS requirements. So 7.2 is Z13 generation and up. As usual, here's the continuous delivery news and page, and that information is updated regularly, month by month, if not every few weeks or so. There's an update to new function or scheduling, or whether it's out or when it's due, or new things coming along. So do try and keep an eye on that. And for each sort of new function and feature there, you can see the important detail about it, when it is likely to be available or when it became available, compatibility, what do you need to do with it, and all of those sorts of things. It's a very useful page. For those new to VM, there's a list of links along with all the usual links to playlists on sort of education YouTube things, which I'll mention later on towards the end of the session. So overview of 7.2, GA'd last September, previewed a while before that, and as usual, the announce was nicely before GA. This new architecture level set, so it's now Z13 and up, so current generation, previous generation, and a generation before that, so Z15, Z14, Z13, and all the corresponding Linux One branding stuff. Includes all the new function that ship with 7.1, as you'd expect from seeing that cadence, including the supporting the enough, plenty more processors. So remember, 80 logical processor support is 40 IFLs, assuming that you've got SMT enabled, and there's pretty much no need to ever not enable SMT now. If anybody isn't, then get in touch if you think you have a really good reason. But ever since the last couple of generations or so, SMT is kind of a a universal win in terms of capacity. As far as I'm aware, there are no kind of weird corner cases left, or if you really are in a tiny corner case where it isn't, then I'd be very interested in knowing. And along with the stuff, the roll-up of the 7.1 new function, we've now got these things, and I will go through bits of each of these as we go through the session. So the centralized service management for GDPS users, the multi-target stuff, this adjunct virtual machine support, which has actually been there for ages, but is now actually documented. And a few default changes, which I'll mention.
Malcolm, just for everyone to know, there is a presentation on this stream tomorrow on centralized service management too.
Good, thanks, Dave. Yep. So I'll mention it briefly in terms of those of you who why you might be interested and why you might not be interested for your sites. And then if you are, then it sounds like there's going to be a detailed presentation on it tomorrow. That'd be great. So yes, synergy for new function APARs. So this is internal stuff. It doesn't directly affect sort of usage of the system, but what it's doing is changing things internally to make these regular introductions of new features smoother and cleaner. So as with any very old piece of code, one can imagine there's kind of a bunch of old stuff and technical debt in there. I'm not a VM developer, but it wouldn't surprise me if that were the case. And so having that sort of cleaned up in order to make it easier and safer to introduce new function is a good thing to do. So there've been a few system default changes. These are just a couple of reminders of those. They're in the leveraging new function presentation, but I brought them into this platform update because I thought they're worthy of mention. TDISC clearing is now enabled by default. So in other words, if you define a TDISC, put some data on there, detach it, and then somebody else gets the same extents on the disk, they are automatically zeroed, which is kind of what you'd expect for disk behavior these days. And as it says, the sample system config files still kind of have it listed as disabled in system config, but the system default itself has changed. The SRM unparking model has changed. Again, what this means is that as the vertical polarization stuff has changed things in terms of how the operating system communicates with Prism to say park this, unpark this. It sort of turned out that medium is more commonly the right thing to do. And I guess just a quick thing for that, for those that aren't familiar, the way I think about it is if you vary online or offline a logical processor, it takes a while. It's probably sub-second, but it has to talk to Prism. It does kind of architectural things, and so it's not something you want to do, multiple times a second. On the other hand, communicating with Prism to say, kind of, is this being shared with another LPAR? I want it for a little bit, you have it for a little bit, and letting Prism have enough information so that it can spread things between LPARs around the mediums reduces the overhead quite considerably. So this parking and unparking is something that you can do. I don't know if it's kind of 100 milliseconds or less or more, but the idea is that it's something the system can do automatically as things go by, as things go along, to avoid that overhead of lots of sort of logical processors sharing the underlying physical ones and kind of stepping on each other's toes. And this just means that in the data from customer usage of these means that the way that they do that has changed this model from large to medium. And if your environment has it better with large or small, then by all means set it. But it's nice to have the defaults fit the most common situation. System recovery boost. So those who are hosting ZOS or VSE guests or whatever, SRB is enabled by default, and obviously you need the hardware, the right hardware generation in order to take advantage of that. Dermate need pass, the default value is now changed to no, hooray. So there's not every time you set up another system, do you forget, you have to start typing passwords in, and if you're using log on by, it's not quite as easy and so on. So the need pass is now no. And within Dermate, the way that it sort of does its timer for checking things and so on, was fine for the old days, where it didn't matter if you sort of waited a second or two, in between things just to make things tidy. These days, when you sort of have lots of changes and when changes can trigger lots of things happening at once, reducing that so that you're not waiting for an integral number of seconds between things and it just goes straight ahead and does it, can actually make it really rather snappier to do things with Dermate. And the SSL, the TLS certificate check now defaults to preferred, as you would expect with security sort of hardening and becoming stricter as time goes by. So focused value areas, improved scaling and total cost of ownership. So fitting more into less and lower costs of running a system. Improving resource management. As usual with zVM, there's all sorts of mixed workloads, from small numbers of large to large numbers of small to everything in between and mixed. Security improvements, as one would hope, and some improvements to resiliency and RAS as well. And then some improved system management stuff, so just things to make actual day-to-day stuff that little bit nicer for us sysprogs. So performance improvement is sort of one that's been called out here. So as Rocky cards and NVMe to an extent become more popular, Rocky cards especially, the overhead in having zVM handle some of that virtualization has been reduced. And as always, remember, if you only ever see ZOS people present and they're talking Rocky cards, they're talking about the amazingly low latency but really rather weird SMC-R stuff. Linux can do that, but remember, Linux can also use Rocky cards as ordinary Ethernet connections. So your Rocky cards with their 2 fast ports, so Rocky cards have 2 10 gig ports or 2 25 gig ports. You can plug those into normal Ethernet switches, and Linux can drive them as a normal Ethernet card. Now, there are pros and cons there because they don't do virtualization the same way as OSAs do. So you can't use them as vSwitch uplinks, but they do, they do virtualize. And if you haven't considered them for that kind of use, then do consider them. Four terabyte main memory support. So as memory requirements increase for everything, that's gone up from 1 terabyte to 2 terabytes and now to 4 terabytes. And that's for the zVM LPAR as a whole. And that's including supporting over commitment. So in other words, just because that's increased there doesn't mean that things are going to go horribly wrong if you start paging even in the slightest. Obviously, the speed of paging is often a concern, and it's too slow for kind of lots and lots of things active and at the same time. But for paging, for getting rid of pages used by idle and quiet guests and things like that, then it's still useful. The per guest limit of 1 terabyte, though, is still unchanged. Automatic standby memory for guests. This is nice. It's relatively simple, but it's one of those gotchas that seem to hit quite often. So if you're familiar with the idea of having standby storage and a guest. So we have a guest here where its default storage as it powers on, as it comes on, is 4 gig, but the maximum that you're allowed is 6 gig. Now, the old architectural way of increasing memory meant that if you did a defined storage 6 gig, then yes, the virtual machine wouldn't be logged off, but architecturally, it completely starts from scratch. So it's kind of bye-bye operating system. So the hot plug memory support in Prism and the architecture and so on is a way of allowing an operating system to add memory while everything sort of carries on running in chunks and take it away again if the operating system supports it. And the way that you present that to virtual machines, to guests, is with a defined storage 4 gig and then telling it how much to have for standby. And the storage and max store numbers, so the 4 gig and 6 gig on the top line there, are kind of quotas to limit that. So if I issued defined storage 4 gig standby 3 gig in my class G virtual machine, then it will go, no, you don't, you can't have that much. The command there means that as soon as a virtual machine comes up, it defines things for you with storage of 4 gig, standby of 2 gig. So the Linux sysadmin there can choose to add 2 gig to its virtual machine, or take chunks up to 2 gig, or take some of those chunks away. In Linux's case, sometimes it can take storage away, sometimes it can't. But the thing there is you've got the 4 gig and the 6 gig numbers in the virtual machine, and if you change that, so let's say you want to allow more standby memory, so you change the maximum storage to 8 gig, you also have to remember to change that command line below to say standby 4 gig. And now let's say you want to change the default amount of memory that it comes up with. So you change that to 8 gig and you change the maximum to 16 gig. Now you have to remember to change the defined storage command in both bits. And on numerous occasions with numerous customers, it always seems to hit at least once that you update one of those numbers and not the other one, and you don't get what you want. So a very simple solution to that, what you can do now is use the keywords initial and remainder in the defined storage command. And now when you use the keyword initial, what it means is the value of the store value, 4 gig here for the virtual machine. And when you use the keyword remainder, it means use the value of the max store for the virtual machine. So you put that text in, command F store initial standby remainder, and then you leave the text alone. Then when you change the max store for a virtual machine to 8 gig, so you go derm for Linux 21, max store 8G, hit enter, it's updated it, and also your defined storage and standby works out and you don't have to go and do something manually. Similarly, if you change max store to 16 and store to 8, then everything works out nicely. Isn't that nice? Dynamic memory downgrade. So we've had the zVM operating system support for taking advantage of the standby and reserved memory, so adding some to a zVM system for quite a long time now, but until now you haven't been able to take it away while the system's still running, and that is a pain. Let's say you have a two-way SSI cluster and you want to do rolling maintenance, so you can add memory. Let's say you've got A and B, you add memory to B, move the workload from A onto B, take A down, apply a service, bring A back up again. It needs to then have enough memory. So either statically or dynamically, you give A enough memory, you move the workload across from B, but now you can't, you spread over A and B again, but until now you haven't been able to take the memory off B, and you end up with this bubble of memory. And yes, you can take down some, test and dev and sandpit systems and so on to have the spare memory while you're doing the rolling upgrade, but you always kind of end up with this zVM system that's too big without being able to take memory off it live again. Well, now you can. So you can't take all memory away, So there's a maximum of 50% that's reconfigurable, and the numbers there. I don't think I've got the chart in this one, but it's in the leveraging new function chart. It kind of keeps track of how much you can remove, yeah, so there's information there that helps you with that as well. ZXC architecture support. This won't affect most customers. I guess if there are, ISVs and people writing stuff within CMS to do things, then they might be interested in this. And kind of the important thing here is ZXC, the XC part is what lets VM use multiple address spaces in a way, but the way that it uses it is used by SFS. So what that has meant is that until ZXC came along, all the stuff that wanted to do SFS with CMS couldn't use ZCMS. Now it can. So really, it makes things easier for like IBM and ISVs that are doing this kind of thing to mean that things that are using SFS can now use the Z architecture. So more memory and nicer instructions and faster and easier and all the rest of it. Live guest relocation. Crypto, the way that VM has virtualized crypto hasn't been as completely architecturally sound as all the other stuff, because it hasn't presented crypto coprocessors in quite such a fully virtualized way. So you've got the APvert stuff, and for when Linux was really just using crypto coprocessors to speed up TLS, then that's okay. They're all doing pretty much the same thing, and the fact that under the covers you had newer generation of crypto cards didn't matter so much. Now Linux is doing much fancier things with crypto coprocessors, and that's with the APvert for the clear stuff and coprocessors, and I guess EP11 as well. It kind of matters a bit more what level some of these things are. So what happens now is that the level of the crypto HSM is kept track of across the SSI cluster in terms of the kind of the bitmap that says what member has what features there. And so as you're live guest relocating around, if you have different levels of Crypto Express hardware on different KECs, that different members are seeing, then things will behave, and it does what you would expect and hope, which is that let's say you have a KEC with a newer crypto card and a KEC with an older one and an SSI cluster across them. If you bring up a Linux guest on the old KEC, if you bring up a Linux guest on the KEC with the new card, now it will present to the guest the older version of the card so that it doesn't try to use new functionality. And so that if you live guest relocate it back to the KEC with the old card, things will still behave nicely. Security certifications. Successfully completed FIPS standard. So FIPS is the crypto stuff, which governments and standards and things like that like to have. What I think is more interesting, and I missed it when it first went by, the common criteria evaluation, EAL4 plus common criteria evaluation has now completed as well for 7.2. There's a link there to the document. I went and downloaded it. Normally when you download these things for IBM doing the common criteria for ZOS and zVM, it's done via the German system. So there's a lot of German documents involved. I see this time they've chosen Italy. So there's Italian documents and signatures and certificates involved. But the pointer there, the targeted evaluation document has kind of an English version of that as well. And interestingly, I think they should have crowed about this a bit more. SSI is included. So the OSPP, the Common Criteria L4 Plus includes SSI, yeah, and live guest relocation and all of that. So this is saying that the strength of the virtualization is carried even within an SSI cluster. That's the certified target evaluation. Some newer stuff for TLS and revoking. So these are ways to tell when a certificate's been revoked. And the way that you have to do that is go and make a web request to ask if it's been revoked. And yes, as you might expect, that slows things down a bit, but if you need it, then I guess you need it. This is for GDPS customers. So you, for quite a long time, being able to have your hyperswap and vector mirroring and so on. So you have your source devices and your target devices, and you've been able to put your target devices in another subchannel set. You can now have 3 alternate subchannel sets. So when you're copying to multiple remotes, you can now put your alternates in up to 3 alternate subchannel sets. And kind of this has 2 things. So some device numbers end up with 5 digits instead of 4. So you have the way that zVM does things is in the first of the 5 digits is the subchannel set, so 0, 1, 2, or 3. In the Linux world, you have the dots there. So you have a 0 dot subchannel set dot for device numbers. And all non-disks still have to be in subchannel set 0. And what happens is when you IPL VM, you can IPL from an alternate subchannel set. So when you load from the HMC, you can put 5 digits in there. And if you load from a DASD device in subchannel set 2, let's say, then what zVM does is it says, okay, 2 is my active set. So it uses all the disks that are in subchannel set 2. Every non-disk device, though, is still just your normal subchannel set 0. And then when hyperswaps happen, they happen kind of live between 2 and whatever you're hyperswapping to. But the active configuration is the one that you IPL'd from. Adjunct support is fairly niche, but it's actually been around for ages and ages because it's used internally for debugging things and so on. And somebody clearly nicely twisted their arm and saying you really ought to document this, so they've documented it. I've had a look at this because I wasn't familiar with it. It doesn't, for Linux use, it doesn't seem to be do things that it couldn't really do otherwise, apart from some obscure cases where I wouldn't debug things that way anyway. But for traditional environments and so on, I think it's it can be useful. So again, it's maybe not useful for most customers, but maybe there are some kind of ISVs or people that would be interested. There's a health checker for Dermate. So Dermate actually in these days of kind of orchestrating lots of microservices, I kind of think of Dermate that way. It's sending things to and from readers. It's linking things to and from data move disks live. It's updating the user directory to do various things. And it has to do that in a way that's reasonably tolerant of other people coming along and taking things away from virtual machines and linking things at the same time. It's tolerant of that, but it does mean that it gets stuck every so often and then trying to troubleshoot, okay, that's because in the middle of Dermate trying to get rid of this, attached it to data move, but I already had a link to that disk from somewhere else, so it couldn't get it, and now I have to troubleshoot what that is. So there's no way around it without Dermate stopping you from doing things with the directory that you would want to be able to do. But there's now a kind of a health checker to do various things for this at that level. So that might be of interest. When things do go wrong, the doing a dump has to be done from a very kind of minimal environment because the system's gone wrong. So you don't want the dump to make things worse. But now it's been improved, so it can at least use ZHPF, so it can actually write those dumps faster. And the other thing is that when you have a full dump, it's dumping all of the kind of the guest memory and information, can be dumping all of the guest memory information or some information about all those page tables as well. And that can make dumps very, very big. Often that information isn't needed, but up until now, you've had to kind of download and upload the whole thing to IBM in order that they can just go and look at the small part that they need. So what happens now is in dump load, there's a distill option so that it only extracts from spool the small amount of the dump that it needs, which makes it much easier to send to IBM. If they then need the full information, that's fine. It's still on spool. You can load the whole thing, but you can go dump load distill just to get the the important information. And it's not in dump load 2, it's just in dump load, but then yeah, it's okay. For e-devices, path management is improved. VM, EDEF has always kind of been a thing for sort of functionality rather than, performance or preferred. If you have to, you have to. But some of the robustness and path selection and things are now improving. So ALUA is where the storage subsystem, the disk storage subsystem, can tell you, I'd really rather you use this path, and not as a static thing either. So if you take, say, flash system, whether it's kind of 7,000 or 7,200, 9,200, whatever, they're built around 2 nodes and two Intel servers, and you'd prefer to be talking to one node at any given time because it's kind of got more direct access to the disks. If one of those nodes goes down because you're applying maintenance or there's a problem, then okay, the other node could get at it. And if it's going down in a managed way, then the other one can now get access to the disks, and really you'd rather it use that path. So ALUA is a way that a disk storage subsystem can even update the operating system about saying, now you really ought to be using this path. So it can use that, and then the other one goes away cleanly rather than just being ripped away. So yeah, if you're using, actually most SCSI stuff will be doing that, and VM now takes more notice of that to do the right things. So here is the trailer for tomorrow's CSM presentation. It lets you deploy service to multiple zVM systems from a primary location. And what happens is it's kind of got its own built-in FTP server. It's a push model. So once you've said that this zVM system is going to be looked after by CSM, you no longer apply service to it yourself. From the central system, you do stuff there and you push that service out to the zVM systems that it's controlling. Different systems can be at different levels. You can sort of manage that nicely. More details tomorrow. Note that this is non-SSI, so you can't use it to service SSI systems. So SSI has centralized management within the cluster. So within the members of an SSI cluster, you apply service once and then put prod on each member. CSM doesn't help with that and can't help with that. So this is only managing numbers of other zVM systems. And if you only have 2 or 3 or maybe even 4 kind of zVM systems, maybe CSM is going to be a bit heavyweight. If you have a large enough number, and what that number is, kind of probably ought to go along tomorrow, then it's definitely worth it. This is a way of getting your service directly from shop Z to your zVM system. If your zVM system has outbound access to shop Z, So it's what ZOS has been doing for ages now. The way that it works is you fire up a get shop Z utility in a CMS machine. It starts up a little web browser, a little web server, and you point at that, and it kind of acts as a staging area. So you log into ShopZ kind of from your normal browser window and go to the place where you download the stuff. You then copy the URLs, switch back to the browser interface to the Get Shop Z, paste in the URLs there, and then this Get Shop Z utility on zVM pulls them from ShopZ directly to, well, typically to your main VRM, 500 disk or whatever. So you don't have to download it and then upload it, and it does some other, checksum tracking and a few other nice things as well. There are environment variables now for all these new functions that are coming along, so you can kind of tell what's running. Full list of variable names there. Spool information enhancement. So this doesn't kind of directly help you with ordinary commands as much, but it improves the API so that software written to use spool stuff can get more information. And one of those pieces of information is, okay, I've got a whole bunch of spool volumes and I've got some spool files here. Which volumes does this spool file live on? And that can be a pain when you're doing DASD migrations in order to try and figure out which volumes are in use and which volumes aren't, and all the rest of it. The diagnose API that lets you query spool information now tells you which volumes a given spool file has any data on, and it also has some extra filtering information. So I think it didn't used to be the case that you could use those APIs. So there's a diag and there's a star SPL info or something like that. There's a star service. It didn't let you query system data files, so NSSs and things like that, and now it can. And so IBM and ISV products that want to do stuff with spool, so for example, IBM Operations Manager for zVM can now use that information to do nicer things. There's always been a way of, I'll say always, for a very long time, there's been a way to set the devices bitmap for real devices for things like, do I want to sense this? Is this going to be, what have you got? There's accepted, not accepted, sensed, not sensed, online to RPL, not online to RPL, and a few other weird things there as well. And it's been possible to set them, but you haven't been able to query what you've set. Now you can. So when you query these things, okay, I haven't got a chart which shows it's in the leveraging new one, but it gives you a nice table that says what all of the bits are for those, rather than you having to keep track of things manually. This is a nice one. So when a guest is exploiting HyperPav, up until now, you've had to do it on full pack disks. Now you can do it on near full pack disks, so one to end disks. So remember that there's two different ways of using HyperPav with VM. One is you can attach the underlying aliases to the VM system itself. And then if you have guests, let's say lots of little guests, each of whom has a mini disk on a big volume, then each of those guests can now do I/O concurrently, because zVM underneath is picking aliases to drive the real I/O. That doesn't help you with a biggish Linux, with a biggish guest, a Linux guest that wants to parallelize I/O itself. And that is happening more often now, for example, because for OpenShift, the disk that you give to an OpenShift node, i.e. as a virtual machine running OpenShift, it only wants to see one disk device for all of its ephemeral stuff, because it's a cut down RH core operating system rather than RHEL. So all it can cope with is one disk, and that disk needs to be big, so 100, 120 gig or more. And if you want to parallelize IOs to that, the guest needs to be doing hyperpath. Now, if the guest is doing hyperpath, you need to be attaching the aliases to the guest so that the guest can see the device numbers to issue parallel IOs against. It doesn't help that zVM has some aliases attached to system if the guest can only see one virtual device. And up until now, you can give hyperpath aliases to a guest to exploiting, hyperpath exploiting guest, but it's had to be a full pack one. And as always, that means that the guest can fiddle around with cylinder 0 and the label by mistake or in theory maliciously. Now you can do it on one to end so that VM is looking after the real volume label. If anybody is doing IPv6 or Ethernet V switches, now you can query the information on them. Help now has some extra subsections. So there's kind of always been subsections for things like CP query. So instead of having to go help query or help CP query and then go and choosing, you can go help CP query whatever something. Now you've got that for source directory statements and system config file statements, so that you can bring those up either immediately or by browsing the sub menu and going to that, which is quite nice. Yet more reports in PerfKit for SMT. And finally, so this is the zVM Council thing. So this is a way, this is one of the main ways now that you as customers can influence and get involved, influence IBM and get involved with the direction of zVM and new features and function and things like that. The requirements are that people spend don't take the mickey, spend a reasonable amount of time getting involved in this, but there is real benefit in terms of projects and influencing new function and things like that. There's a nice new set of pages for problem determination, for must gather information and troubleshooting and things like that. So whereas I used to find myself kind of writing things up individually for some of these and cutting and pasting from previous things I'd sent, there's some nice web pages here which take you all through it, which is rather nice. There's now an educational work group as well. So there's the consuming videos for education is now a lot more popular than it used to be, and people learn in different ways, and some learn verbally, some like seeing pictures, some sort of learn interactively, but learning by sort of watching and videos is a real thing now where it really is helpful for some people and they learn a lot better that way. So,
Malcolm, there's a question
yes?
in the chat.
Yep.
Can you remind us about large page 1 meg 2 gig support for Linux and ZOS guests under zVM?
No change basically. So yeah, that's not terribly nice news. So yes, architecturally, now hang on, let me get this right. Architecturally, the guest will see the 1 meg pages, not the large pages, but under the and so the guest doesn't need to have as many page table entries to look after things and not as much meta information. But under the covers, zVM itself is still dealing with 4K pages. So the actual page table entries in zVM and the underlying the TLB, the translation look-aside buffers and things like that in the hardware aren't benefiting from it. There's somewhat of a fundamental design decision for that, which is that one of the reasons why zVM is very good at managing sort of lots of mixed guests doing lots of different things in a kind of lightweight and efficient way is all pages are kind of 4K from that point of view. If an operating system decides to manage things with different granularities, so 4K and 1 meg or 2 meg and 1 gig or 2 gig, and depending on architecture and things like that, it really complicates memory management quite a lot. And for kind of seeing how that can go, if you have a look at Linux, yes, it can optimize a lot of the functionality, but if you look at the transparent huge pages and can you hot plug memory if it's being there or not, and so on and so on. And actually, even those looking more detailed, there's the significant changes to the Linux memory management now in terms of setting up for coping with a lot of this more complicated stuff, things called folios and multiple pages going together. So having that decision for memory managing different sized underlying chunks is difficult, and there's overhead and complexity in doing so. At the moment, zVM is staying with the most efficient light way of doing it, which is everything is 4K pages. Maybe at some point they can kind of go the halfway house. They might or might not decide to do the halfway house model of ZOS, where again it's sort of very static. I'm going to assign this chunk of memory to this side of pages, and then you're putting the blame and the responsibility on the sysprog for getting the number right. And if you get it wrong, then people run out, or you're using memory that you should have used as smaller ones. But having the operating system able to kind of break large ones into small ones, and then even more difficult, reaggregating small ones to make big ones again when you might have fragmentation. There's fundamental complexity there. So it's not just that they haven't done it and they should have done it. It's a fundamentally difficult thing to do. But yes, at the moment, the guest operating system gets some benefit because it can deal with the large pages and doesn't have to have its own metadata. But at the hardware level, you still have you're still paying the overhead there for the benefit that zVM is always going to have, pages that it can do things with, rather than have to stall or suspend guests or spend lots of CPU time trying to trawl through lots and lots of fragmented things, trying to build large chunks of pages. Okay, that's my opinion. So yeah, educational work group. 2 types of videos, and there are links there to some of these how-to guides. So for those that want to do that, there's the VM YouTube stuff. So summary: we're still on 7.2. 7.3 didn't arrive while you were looking away. Yep, it's still 7.2, and because of new cadence, new functionality is going into that all the time. So don't wait for 7.3 to see what's there. Go and have a look at that continuous delivery new function page. Enhancements include CSM, which, as Dave says, you will be hearing about tomorrow if you attend that presentation. And for GDPS users, the multi-target PPRC stuff is in there now, along with all new functions shipped for 7.1. 7.2 is still the current release, so new function is still continuing to be delivered on 7.2. Go and have a look at that new function page to see what's there now and what's coming. And the VM website stuff there is nice and clean and efficient. It's not one of these broader IBM things where things tend to break and go wrong and functionality gets removed and it's horribly slow. It's just nice, small, efficient, but it is now updated regularly for a lot of these things, so do follow those. Finally, any questions? I guess, Dave, if you just have a look at the chat and let me know, because I can't see the chat from here.
Yeah, there's nothing there so far. They're a shy bunch again.
Okay. In which case, as always, thank you for attending at 9 o'clock in the morning for a remote conference. These are my contact details. And this is a GSE session. This is session 2AS. So please do fill in your feedback. There's a link to it there. There's a QR thing to scan if you want to do it that way. Please go and give that feedback. That's the end of my stuff. So if I hand back to you, Dave. Thank you, everybody.
Okay, thank you, Malcolm. And thank you, everyone, for attending. We'll see you at the next session. Cheers.